Hey guys, so as you notice, I'm not here today. Don't really want to get too much into details of where I am today. This was kind of unplanned last minute, but I don't know if I've told you before. My dad, he got diagnosed with Parkinson's probably about 2 years ago, and he's starting to get some fairly significant issues with it. So I'm actually at a doctor's appointment with him today to find out, what's been going on. So, anyways, I can talk to you more about that, anyways. But just do me a favor, go home and enjoy time with your parents, because sometimes you just never know. But, anyways, on that happy note, so I'm not here today, but I do want to make sure you actually learn something and not just have another day of doing 10 minutes of work and then 80 minutes of whatever. So I have these notes pre-recorded. So I'm going to kind of go through this somewhat fast just so the video file isn't super huge. So if you need to pause this at any point to write down some notes, just go ahead and pause it and jot some notes down. Whenever I get to some of the examples, pause it, try it on your own, and then see what the answers are once I show them to you. So anyways, first type of reaction we're going to go through is called a combination reaction, also referred to as a synthesis reaction. Either way is fine. I prefer combination because that's what you're doing, is you're combining two things to make one. So it's going to look something like this, where you have two reactants, so A and B, A plus B, those are your two reactants, and then you're going to make some new compound. So that's why A and B are combined on the right side, and on the left side they're separate, because that would be saying you have chemical A, you mix it with chemical B on the left side, and on the right side you have this new product, this chemical AB. Anyways, things to watch for is make sure whenever elements are by themselves, a lot of the elements you can write as individual atoms, but there are the diatomic elements, so the Brinkelhoff elements. And then whenever you write the new formula, you do have to make sure you get the right charges to figure out what the correct formulas would be for those products. Okay, so for example, if we were making a salt, so we have sodium, we're going to react it with chlorine, what would that give you? All right, so the one thing you want to avoid is don't just say that sodium chloride. Oh, I forgot to do something. Hold on. Okay. All right, so whenever you figure out the formula, first thing you want to do is make sure you write the binary compound. So write your product. So you always want to, the order on the left side doesn't matter. We could write sodium plus chlorine. We could write chlorine plus sodium. It's like in a recipe. Sometimes in a recipe it says mix your flour and salt and eggs. And you could mix flour and salt then eggs, or you can mix the eggs and then the flour and then the salt. It doesn't really matter. Well, maybe some recipes it does, but in my culinary experience, I don't think it really matters, but whatever. Anyways, so what I want to do is I want to write sodium. Let's see, this. All right, so we want sodium followed by chlorine. Okay, so that's the first part. Second part is make sure you get the right formula. So you have to identify your charges. So you look up sodium, it's in group 1, that's a +1 charge. Chlorine's in group 17, that's a -1 charge. So +1, -1, you just need one of each. All right, so notice that I'm not writing the formula NaCl2 because, I have 2 chlorines on the left side, I need 2 chlorines on the right side. Okay, that's not the correct formula for sodium chloride. All right, so you have to go with whatever the charges are. So Na plus Cl2 will give us the correct products. So once you write the correct formula, then make sure you get the right formula and then balance the equation. So now you have the right formula. Now to balance the equation, we can only put the numbers in front of the chemicals. So if we have 2 chlorines on the left, we need to get 2 chlorines on the right. And now that gives us 2 sodiums on the right, so we get 2 sodiums on the left. Okay, and these reactions should be fairly easy to balance. Hopefully not a lot of big numbers like we were doing the other day. So hopefully they're not too bad, but you'll get a lot of practice balancing with the next few reaction types we go through. Okay, so if I was there, and you can honestly, after this is done, you could go on YouTube and find this reaction. So I'm going to react magnesium with oxygen. So you just take a piece of magnesium, you mix it with oxygen. Now, you might just seem like, well, wind it just naturally mix with oxygen because there's oxygen in the air. Well, that could be the case, but we need a catalyst. We need to add heat. All right, so there's where our catalyst goes, and the delta symbol just means heat. Okay, so once we add a little bit of heat, the magnesium reacts. It's a pretty cool reaction. Definitely check it out. And we're going to get our product. So we would get magnesium bonded with oxygen. Figure out your charges. Magnesium is +2, oxygen's -2, so we have +2, -2. We just need one of each, and then we need to balance the equation. Okay, so that's what that would be the demo if I would be there. I'm not going to make the sub do that because that would probably not end well. So anyways, there's that, and yeah. All right, so now with transition metals, so if I gave you something like this, where I have, now first off, it's nitrogen plus copper. So whenever you write your product, right, so first figure out what would go first on the product side. All right, a lot of students would say, oh, it's nitrogen bonded with copper. But remember, it's always your metal, then your non-metal. Or better yet, it's always your positive charge, then your negative charge. So this would be copper with nitrogen. All right, so nitrogen, it's in group 15, so that's think about it, hopefully you said -3 charge. Copper, what's the charge on copper? Well, if you look on your periodic table, copper is a transition metal, so it has multiple charges. So you're not sure, do you put +1 or do you put +2? So to figure that out, really you're not going to know unless you would do the reaction, but we're just going to make life easy. And what you want to look for is, look for the most common charge. So if you look at copper, the most common charge is the oxidation state that is bolded. So look above, on your periodic table, look above Cu and below the atomic weight, and you'll see +1 and +2, but +2 is bolded, so we're going to go with +2 for the charge there. Okay, so that's what you would do with transition metals, go with the most common charge. And then to balance this, you would need 3 here and a 2 there to get the neutral formula, because that would give you +6 and -6. And now to balance this, we just need a 3 there. Okay? So if you have main group metals, they only have one oxidation state. Transition metals, you could have that happening. All right, so take a few minutes, see if you can figure out these examples. So again, pause the video. Try these 3. Once you think you have them, check with your neighbors, see what they got. And again, make sure you figure out what the product is and balance it. State symbols I have listed there, but you really don't need to include state symbols because you're not going to know what state the product would be in. You wouldn't know that unless you did this with experience. So anyways, go ahead, pause the screen. I'm going to go through the answers here, but go ahead, pause it, see what you come up with. All right, so hopefully you did these. The first one, lithium plus chlorine. Lithium would come first because it's your positive charge, it's your metal. Chlorine would come second. Lithium is +1 because it's in group 1. Chlorine's -1 because it's in group 17. So that's your correct formula for your product, and then balance like that. For the next one, oxygen plus sodium. So be careful on this one. A lot of students will say oxygen bonded with sodium, but sodium is your positive charge, so that's going to get written first. So you would want sodium, then oxygen. Sodium is +1, oxygen is -2. So you need 2 sodiums for 1 oxygen. And now to balance this, looks like a 2 in front of oxygen because you have 2 oxygens on the left, you need 2 on the right. And then that gives you 4 sodiums because 2 times 2 gives you 4 there. So make sure you watch that. And then the last one, cobalt bonded with fluorine. So cobalt, look on the periodic table, +2 and +3, but +2 is bolded, so go with that. Fluorine is -1, so COF2. And then to balance it, well, look at that, it is balanced. So, all right, so that's one type. That's one type of combination reaction. You could see an element plus an element, but we could also have a compound plus a compound. right, so here are the three compounds you could see, and that's called forming a tertiary compound. So it just means a compound that has three elements in it. All right, and here are your three examples. So first off, you're always going to have, and again, this order doesn't matter. You could have water plus metal oxide or the metal oxide plus water. The order on the left side doesn't matter. So any type of metal oxide, so on your periodic table, any element that's on the left side of the periodic table, on the left side of the steps, that would be a metal bonded with oxygen. And then if you get any one of these three as your other product, well, hopefully this will help. Notice on the first one you have water and you're going to make a hydroxide. Well, think about what's the formula for hydroxide. So remember, hydroxide, one of those polyatomic ions, it's OH and it's -1. So OH, very similar to H2O. The next one, CO2, carbonate. Well, let's see, that's CO3. And hopefully you remember it's a -2 charge. So no CO2, CO3, very similar. And then sulfate is SO4 with a -2 charge. So SO3 to SO4, pretty similar there. Okay, so three examples where you could see this. I'll just give you the three and you try them. Okay, so go ahead and try these three. Again, pause the video, try these three, and see what you come up with for an answer. Also, make sure you balance the equation too. Okay, so hopefully you did these. Check with a neighbor to see what they came up with, but let's go through this to finish this off. So the first one, magnesium oxide plus carbon dioxide is going to give you magnesium as your metal, and then CO2 is going to give you carbonate. So magnesium is a +2 charge, carbonate is -2. So that formula is balanced, and then balance the equation. Well, 1 magnesium, 1 carbon, 3 oxygens on both sides, so it is balanced. Look at that. Next one, beryllium oxide. So you're going to get beryllium. You have water, so water is going to give you a hydroxide. Beryllium, it's in group 2, so that's a +2 charge. Hydroxide, it's -1. So we need 2 hydroxides. So remember, if you need more than 1 polyatomic ion, put it in parentheses, and then the number you need on the outside. All right, balance it. So 1 beryllium, both sides, 2 oxygens, 2 hydrogens. So we are good there. See, these are easy to balance. Next one, a little trickier to balance. Aluminum oxide plus SO3 sulfur trioxide. So you're going to get aluminum, that's +3. SO3 is going to give you sulfate, which is SO4 with a -2 charge. So if you have +3 and -2, that means you're going to need +6, so you need 2 aluminums, and then -6, which means you need 3 sulfates. All right, so now to balance this one, it looks pretty tricky, but balance your sulfurs. Your aluminums are already balanced. You have 2 and 2. Sulfur, you have 3 sulfurs on the right side. We need 3 on the left side. So if we put a 3 there, and then check your oxygens. You have 3 here, 3 times 3, so that gives you 9 oxygens. That's 12. On the right side, 4 times 3 gives you 12. So hey, it's balanced. So the one thing, if you write the wrong formula, what you'll notice is that it's probably impossible to balance if you write the wrong formula. So if you think you write the correct product and you're trying to balance this and you're constantly going back and forth and adding numbers and it's just you're in this constant loop, this constant cycle, just stop, look at your formula, and I guarantee you it's probably wrong. That's why you're having issues with that. So, okay, so that's really it for synthesis and combination reactions. So for some practice, just do the next page in the homework packet. So I think it's labeled as page 2, although that might be wrong. I'm just checking right now. But that's pretty much what we'll be doing. Is we'll do pretty much a page a day. Yeah, it is page 2. So there's 14 of them. Should have plenty of time to do this. So hopefully I will actually see you guys on Thursday. So that way we can go over both page 1 and page 2, see if you have any questions on that. So anyways, I hope this video did okay for you. Hopefully with pausing it and doing it at your own pace, But again, hopefully that helped. But again, make sure you try it on your own. And if you have issues, that's fine. We'll take as much time as we need to um, on Thursday when I see you guys. So hope you have a nice day, guys. Again, if you see your parents tonight, just tell them what you think of them. Hopefully it's good, because sometimes you just never know when things happen. So anyways, I hope you have a good rest of your day, and I'll hopefully see you guys on Thursday.